So in our next project, we're going to draw this coupler drawing. Now what I've done is taken a snippet from it from the snipping tool and just pasted it right in SolidWorks so I don't have to go back and forth as I'm talking about it, and I can just point out the dimensions as we're going. Now for you guys, you can go over to Google Classroom, and it is posted as a PDF in Google Classroom. So we're going to draw all three of these components. We're going to do the part files first, and then we're going to create an assembly. And after we create the assembly, we're going to create working drawings of each part file, and then an assembly drawing where it shows how to put the parts together. So at the end, we should be able to actually create this part. If we took it down to the machine shop, we should be able to make it, because we're going to have all the dimensions, everything that we need to produce it and to assemble it. So we're going to go back over to SolidWorks, and the first thing that we're going to do, if you're not already in a new part file, which you should be, but if you're not, remember it's very simple. You just, on the home page, you just go to new part and hit OK. So we need to go ahead and change our dimensions. What kind of dimensions are these? If we look at the dimensions on here, we're in English units, right? So we're going to be in inches. By default, yours should be in inches, but let's just check it, make sure. So we're going to go to Options. And remember, this first tab is the options as far as the whole system. But our particular document that we're working on right now, this is the Document Properties tab. We're going to be in ANSI because that's the Imperial Units standard. We're going to click on Units, and we are in inch pound second. Now, if we look at the dimensions, it's okay to still be in 2 decimal places, but here we've got one that's in 3 decimal places. So we're supposed to, the rule of thumb is whatever tolerance value you hold is how many decimal places that you should have. So we're going to go ahead and change that to 3 decimal places. So inch pound second, and then the number of decimals is going to be 3. So we're going to go ahead and change that. Angle, we'll just leave it. You're probably not going to go lower than that on the angle, and then the mass, we'll leave it as well. So the length, which is a distance dimension, we want 3 decimal place precision. So we're going to hit OK and get out of that. And now we're going to start drawing. So let's kind of zoom in here. Probably the best part to start on, the easiest part, is the one in the middle here, this middle bracket that goes in between the couplings. And it's actually, this would be made of rubber, and then the couplings themselves were a steel alloy. So how would we make this? Remember when we talked about design intent, that was our plan that we were going to map out as we go, or before we go, so we know exactly what steps we need to create. So we're looking at this, we're given diameter, so we know that this is a radial or a circular cylinder here in the middle. And then the outer diameter is also circular. And then we've got these edges that look almost like a gear. So what we're going to do there is just an extrude. And we could do just an extrude with this smaller inside diameter, and then create one of these teeth. If we are calling this a gear-like object, we'll create one of these teeth and we'll extrude it, and then we can do a polar array to copy those. So that's probably going to be the easiest thing, rather than try to create all of that geometry in one sketch. So we're going to start on the front view, because if we put the front plane up here, if I zoom out a little more and have my front plane facing, that is the way it's going to be facing when we put this assembly together. So we're going to start on the front plane. Again, that's part of our design intent. We want the end product to look as if it was going to be assembled together. So we're going to click on the front plane. We'll go ahead and start a sketch. And our sketch is going to be, like we said before, we're just going to do this small inside diameter, so that 1.5 diameter, and that's basically just going to be a circle. So we're going to start at the origin, because that's good design intent, and everything is symmetrical and it's going to line up. So we're going to create that, and we're going to put a smart dimension on it of 1.5. All right, and once you have it dimensioned, you can see that your sketch is fully defined. We can go ahead and check out the sketch, or we can skip that click and go straight to features and go to extrude. Now, what is my extrude distance? If we look up here, it's going to be 0.5. So we're going to type in 0.5. We don't have to change anything about the end condition because it's already on blind. And we'll check it off. So now we're going to check out of the extrude, and we're going to go ahead and create the teeth parts. So if we look at this, we're not really given any dimensions except for the width, but we can kind of justify our dimensions based on what we know of this object. So we know that this fits together. There's 3 prongs on this side, 3 prongs on this side. Those 3 prongs are going to fit in the slots here. So if we do 3 into 360, which 360 is how many degrees is in a circle, we're going to divide that by 3 because we have equal pieces. That's 120 degrees apart. So each one of these prongs are 120 degrees. And then if we look at the other coupling, those will also be 320 degrees apart, but they'll be offsetted to fit in every other slot. So this one is actually, if we were to draw a quadrant line straight up from the center of that hole, this one would actually split that quadrant. So we can kind of figure out what angle this should be at. And then we also have the distance here. So we have everything that we need to know. Okay? So basically, we're just going to add this geometry and then we'll array it. So we know it's 0.44, a distance of 0.44. And we also know our angle here, assuming that it's going to be the same. It looks like that these are at a diagonal, so it keeps that same angle all the way across. So to create this, we can either start back on the front plane, or we could choose this surface. Either way, it's not going to matter a whole lot. So just choose that front surface, and we're going to choose sketch to create a sketch on that surface. Now, because this is offset in our assembly, doesn't mean that we can't make this one straight up and down from our origin. Because in our assembly, we can rotate that to match. So for us, we're just going to make a center line straight up. Even though in this pictorial, it looks like it's offset by the angle. So our first step, once we're in a sketch, is to go up here and choose center line. And we're going to start on that origin and just make our center line straight up. And we want to make sure that it is vertical. So that yellow constraint that we see, that geometric relation that pops up, tells us that we are indeed at 90 degrees. So center line, if we look at this again, center line is, if you do the down arrow next to the line command, you're going to click on center line. Now, if you accidentally just choose line and don't choose center line, then you can create a line. Let's say I created that line, I can make it for construction if I need to. So we can make any geometry turn into a center line if we need to. I don't really need that right now, so I'm just going to delete it. This center line, we're not going to put at any certain length, not for now. We'll go back and create some of this other geometry, and then we can figure out what we want to do with it. But for now, just make it straight up and just make sure it's vertical and it's anchored to the origin. So if we look at this, that outside diameter is 2 inches. So our next step would be to create a circle that has a diameter of 2 inches. So that's what we're going to do, and it's a concentric circle, meaning it shares the same center. So we can start that from the origin and just create it out. Remember, we don't have to type in any distances there at the front end of it, but we do have to go back and put a smart dimension on it. When you click on the circle to start, see this little orange dot that comes up? That tells you that you're concentric. And you can also see that little symbol out beside my arrow. That tells me I'm right on it as well. And you're going to have this concentric mate pop up too in your sketch. So those 3 things are going to help me know that I'm right on the origin. So that, putting on that dimension, it's going to be a 2. And now if we just kind of look back at this object, we know that it is 0.44, and that's going to be centered up around our center line. So we're going to offset 0.22 on each side. So I need to get out of Smart Dimension. 2 or 3 ways I can do that. I can hit Escape. I can come and unselect it up here, or I could have right-click and choose Select to get out of the command. So Offset Entities is here. We're going to click on that offset. We're going to choose our center line, and then we're going to choose bidirectional because we want the same distance on both sides, and that distance is going to be 0.22. And we will add dimensions. Select chain doesn't really matter because we only have one entity anyway. And you should see your lines showing up on either side, and we're going to check that off. So when we check it off, we can tell that it did what it's supposed to do, and we can see that there is a dimension on there that allows us to know that we are correct. So what's showing up here is the geometric constraint that we put on it. It tells you that this line is in relation to your center line because we offsetted it. And if you just hover over it with your mouse, you can see that it's an offset line, and it tells you which lines are offset. And then this one was our vertical line that when we created that center line and told it to be straight up from the origin, that just tells us that it is straight up and it's at 90 degrees. So what we're looking at here, we do have all the geometry, but we don't really need this line. We don't need this line. We could actually trim the center line right here so it'll come to the edge of the circle. And we can trim out here. We don't need the rest of that circle. So in order to finish this drawing, right now it says we're fully defined, but we really need to trim up. We want a closed loop shape for our sketch. In order to get a closed loop, we still have to make this line. So even though we have geometry already made and it looks like there's a line there, if we rotate, there's not really a line there. But we can easily bring this edge, if you click on this edge and go to Convert Entities, it's going to convert that edge to our sketch. So now if I go back to normal 2, this edge is already in there. Okay, so we can see that we have a closed loop if we come in and trim out where we need to. So the last step for this sketch is going to be trim entities. Now, SolidWorks has several different trim options. If you're an AutoCAD user and you're coming into SolidWorks, the trim to closest is probably the most similar to AutoCAD, but Power Trim is definitely going to be your best option most of the time when you get used to it. Now, Power Trim, the way it works is you've got to draw, it's almost like you're drawing a line. So I'm going to just out here in space, I'm taking my mouse and I'm holding down my right mouse, or my left mouse button, I'm sorry. So your main mouse button, and it looks like you're drawing a line. But anything that that line goes through is going to trim. So if I put it through here, it's going to trim, and it's going to trim automatically up to the next entity, and it's going to put a relation. So I know that line is coincident or on top of my circle. Now we do not want to trim the center line down here, so don't get crazy and just draw a line through everything. We only want to trim those 2 lines on the edges. Don't trim your center line, at least right here, because then we'll break that relation between the origin and our center line. But we can trim the center line up top. That's okay to do. We wouldn't necessarily have to, but we can. And we also, since we brought in this whole entire edge, we want to trim the rest of that circle. And when we do that, we now have a closed loop. And you can see that it's highlighted for us to go ahead and extrude that. So I'm going to check off the trim. So if you have any extra lines, then it's not going to come in as a closed loop, so it's not going to be highlighted. So if you have extra lines other than your center line, the center line doesn't count. Like the center line does not count as part of the geometry. So you need a closed loop where all the corners are coincident and everything is closed in, there's no gaps. And whenever you have that, you should see fully defined on your sketch. And that means we have all the dimensions and all the constraints we need to create this geometry. So even if it's not highlighted, because sometimes it may not be highlighted. In this case, mine did, but if it doesn't, that's okay too. Let's go ahead and check off the sketch, and I'll show you in the extrude what you can do to help yourself on that. So let's click on extrude. And my extrude is going the wrong way. So the first thing that I'm going to do on here is just tell it to change the direction. So that's that first button beside where it says blind. I'm going to click on that button and it's going to go the opposite direction. Now, I don't want to just say blind on here, because if I have to change this object, let's say I need to go in and change this depth. I want the depth of my extrude now to always line up with the depth of this extrude. So instead of saying blind as my end condition, I'm going to say up to surface. So click the up to surface, and it's going to allow me to choose the surface. So I want to say that my sketch, this extrude, should always go to this back surface. That way, if I do update something, this is going to update automatically with it, and I don't have to go in and change several different things at one time. Okay? So if yours is doing something that it should not do. Let's say that your sketch is not all the way closed in. You can come down here. Sometimes it'll allow you to select the contour. So right now my contour is that whole sketch, which is what it needs to be. So, you know, for me, I could just check that off. But let's say that yours is picking up something different. You can choose the select contour and click inside those contours. So maybe you forgot to make this a center line and you actually made it a regular line. You could click this side and just choose the contours instead of just doing the whole thing. So then I'm going to check that off, and we now have that first tooth. Okay? So I know some of you have questions, so we'll kind of pause right here and I'll come around and answer your questions. So now all we have to do is make an array of this object, or that last feature that we created. So there are how many spaces here? How many of these entities? 1, 2, 3, 4, 5, 6. We knew that because we have 3 on this side and 3 on this side. So we knew that those would have to fit in the spaces. So what we're going to do is just choose that Boss Extrude Feature 2 that we created. And we could even rename this just so we don't get confused. We could rename this Tooth, just so it helps us to remember that's what it is. So we're going to click on just that extrude, and we can come up here to pattern. Now linear pattern is actually showing, but we want to choose the circular pattern. So we're going to click on circular pattern. Now the direction, we don't have an axis showing up just yet, but the direction it comes from the axis. So we need to come up here with the eyeball and choose temporary axes. So whenever we click on this button, it allows us to view that temporary axis. And you'll have a temporary axis on anything that's symmetrical or cylindrical. So basically like a hole or a cylinder, it'll put an axis there for us because it'll line it up with the center of there. So this direction 1, we're going to click on the axis, and then we can see the preview starting to show up. We are going to have 6 instances, so I don't have to change that, and we do want to go 360 degrees. So we're good. Since we chose tooth already, it knew what to copy. Had we not chosen that, we would have had to choose it from our feature tree. And the way we get our feature tree to show up when we're in a command is just to go over here and expand it out by clicking the arrow, and then you can choose it from here as well. So everything looks good. It looks like it's going to copy well. We'll just check that off. And now we have our part. Quickly here, we're going to go ahead and do a save. Let's do a file, save as, and we're going to save this as coupler part 1. Now we could, go in and see what it was actually called to see if there was another name to it, or we could come up with a name like spacer or end piece for the ends, but just do coupler part 1. We'll hit save, and you may have to go and find where you want to save it at. So you may have to scroll to your folder that you're saving it in. So that was the first part. Now we need to go to File, New, and we're going to create another part. So we're going to hit OK. Now on this part, I don't have my drawing on here, so I'm going to show you how you can get that. All you have to do if you have a newer Windows model, which you have to run SolidWorks, you can bring up the snipping tool and just snip a picture of it and come up here and say edit, copy, just minimize that, come back into SolidWorks and just paste it right in there. So we go to edit, paste, and it allows you to paste a picture, and then you don't have to scroll back and forth. But at the end, we want to delete that picture. We don't want it to be a part of our drawing, so we want to delete it before we do anything else. So we'll draw this back piece, this end piece. So what do we know about it? We have very little dimensions just on this piece, but we know just from the spacer part that we just did that that inside diameter between here and here is going to be 1.5. We know the outside diameter is 2. And then the other parts, because these are basically symmetrical parts, they're the same on both ends. So actually we really only have to draw one of these. We have 3 parts, but since these are the same, all we have to do is draw one of them and insert 2 of the same part into the assembly. So let's look at these dimensions. We've got 1.38 for the entire depth here, 0.62 back to where this lip starts. From there, that thickness is 0.25 to the center of the hole is 0.31. Yes, they should be the exact same. Now, it doesn't look like it because it's rotated a little bit. See how this is rotated to offset from where we are here. So it looks like in an assembly, you want to explode it so it's lined up as if you were going to assemble it. So this one is just straight upright, and then here that's rotated. So it looks like 2 different parts, but it's actually the same. And you can see this hole is lined up with a keyway because that hole is for a set screw to go to the keyway. Alright, so other things that we can look at here, the outside diameter for the smaller boss on the front is 1.25, and then the, which we already said this outside diameter is 2. So we're going to start out, I'm going to show you how to do a revolve. Because this is a cylindrical object, we can do this boss here and up to this point right here, up to this 0.25 dimension edge. We can do all of that with a revolve. Okay? So we're going to start out, this time we're going to start out on our right plane because we're doing a revolve. And in a revolve, we really only need half of the profile. And I'll show you what I'm talking about. Let's create a sketch. And when I say half of the profile, we're just going to draw from the center line up, as if maybe you were doing a section view, if you were drawing this in AutoCAD. So we are going to start out with a line right here, and we'll just make that line straight up from the origin. No certain amount. It's probably not going to be that long, but I went to the line command, so I'm clicking on line, and I clicked on the origin to make sure I'm coincident with the origin, and you also want to make sure it's a vertical line. Okay? If something happens, let's say that you didn't make that a vertical line, we could click on it, and over here in the line properties, we could tell it to be vertical. So you don't have to delete your object just because it didn't get to be vertical. Let's just do a normal line for now, and we're going to trim. So the profile here, if we go straight up over, straight up again, and over, and then come down to the center, we can get our profile. So again, to make this line straight, we're just going to click on it, and you can click on vertical over here. If it already has vertical, it's going to show up with the relation. All right, so we're going to go back to the line, and we're pretty much just sketching this profile. So I'm going to just make it proportional. You don't want to make it so that it's not proportional with what we need. So the object is going to look something like this. We still have to go back and put dimensions, but I just made a line straight up, over, a smaller line straight up, and come down, and I made sure that this was in line with my origin. If it happens not to be in line with my origin, then we can do things to make it line up. We can click on the line and hold down Shift or Control and click on the origin and tell those to be in line with one another. Since mine are in line, there's nothing that it's suggesting we do. So once we have our profile, we can go back and put some of these dimensions in. Now I want you to notice we have a hole in the center. So when we have a hole in the center, then we can go ahead and implement that hole in with our profile. What that means is we just put a little bit of space in between the center of the object and where the actual visible line would come in. So what we're going to do here, we're going to change this bottom line into a construction line. So remember, I told you you could change any of those lines to a center line just by choosing construction. So select that bottom line, tell it to be for construction, and go ahead and check off of that line. So now I have a center line. I no longer have a closed field loop, but what I want to do is add another line to my profile. So I'm going to click on line. Yep, it says for construction. So if you click on line, you can choose for construction over here. So the next step would be to choose the line command again, and we're going to create another line, and this is going to be our visible line across the bottom. So we're actually going to trim out right here and trim out right here. And what might happen if we trim here, we may lose our connection to the origin. We will lose it because we're going to trim, and I'm going to show you how to get that back by adding relation. So once you're at this point where this is a center line and this is a regular line, you can go up to Trim Entities, and we trim both of those lines. So we still have a closed-in object. Notice we're still very underdefined. It should stay underdefined because we have no dimensions on here whatsoever. All we have is a few relations on here. But after you trim, just check that off. We're going to start filling in the dimensions and adding geometric relations that we need. So the first thing, we want to be back in line with our origin. So in order to be back in line with the origin, what we're going to do is click on that line, hold down Control or Shift, either one will do the trick. And then over here in the Properties button, it tells us, hey, you can do all of these things with those two entities. And it shows the entities that we selected. So with the line and the point that we selected, we're going to tell those to be coincident. That just means that they're lined up and connected to one another. And we're going to hit the check mark. Notice it turns that line that we selected into a fully defined line. Now the rest of the sketch is still underdefined, but at least it knows where it is in space in relation to the origin. Now, all we have left to do is put in our dimensions. So the dimension on this top surface is 0.62, and then on the elevated surface is 0.25. So let's do those first. So this line is the line that's 0.62, so I can choose Smart Dimension. I can click on that line and bring that up. That's 0.62. And then I can choose this line and tell that line to be 0.25. Okay, and slowly we're starting to get fully defined lines, but we're still underdefined as far as the entire sketch. So we have the horizontal dimensions we need. We still need the vertical dimensions. So those dimensions are actually these diameter dimensions that we're going to bring in. And we're going to need 3 of them. We're going to need this, well, we won't need, let's see, we won't need the 1.5 just yet, but we will need this 1.25, we'll need the 2, and we'll need the 0.625 diameter for the hole. So let's do the outside diameter first. That's a 2-inch diameter. Actually, let's start with the inside diameter, because if we work from the inside out, it's less likely of a chance that it's going to change our geometry where we won't be able to, or we'll have to drag it to be proportional again. So what might happen is if we did this dimension first, that line might move down past this line, depending on how we sketch this profile. So if our geometry starts changing, then you just want to hit undo and try the smaller dimension first. Or sometimes you do have to actually move the lines back up. You may have to delete your dimension and move the lines by hand. But let's try it this way. We're going to do that 0.625. So go to Smart Dimension, and we're going to choose this bottom line. Then we're going to choose the center line. And then we're going to go down below the center line. See how it makes a diameter dimension for us? So I'm going to click, and it's going to allow me to put that 0.625. And it knows that it's a revolve, it knows that that should be a diameter, and it allows me to do that. So the way I did that again was click on this line first, click on my center line, and then click below for my last click, and it lets me set that as a diameter dimension. The next dimension is that 1.25, and then we'll do the 2. So for the 1.25, we're going to click on this line. We're going to click on the center line, and we'll click below the center line, and then type in 1.25. And the last one, the 2-inch, is this outermost diameter. Click on the center line and click below the center line, and that gives us 2. So when we have all of those dimensions in there, and they don't have to be exactly lined up, but sometimes it's helpful whenever you are importing your dimensions into your working drawings. If they are kind of centered and lined up, it imports them where you have them according to your sketch or your part profile. So it does help to kind of keep those close and not dangling way off the edge of the screen or anything like that. And also, if you have to go back in here and change anything, it's helpful to be readable and clear. So once we're at this point, we can check out of our sketch, or like I said, we can skip that step and go over here to features, and now we'll choose revolve feature. So far we've only done an extrude, but now we can do a revolve. it automatically picks up that we want to use the center line as our axis of revolution. Okay, because we made that a center line, it picks it up as our axis. It is assuming that we want to go a full 360 degrees, and we do. So our preview looks good, and we're going to check that off. And now we have the cylinder, the main part of that cylinder. Okay? So unlike this part where we just drew the inside diameter first, now we're working from the outside in. So when we actually do the sketch for this tooth, we're going to have to work from the outside diameter to the inside, which is no big deal. We can do that. But we have to figure out, we're going to have to do some construction geometry in our sketch to figure out what this angle should be. We know that it is a congruent angle because it's lining up with the other side. We just have to make sure that we're keeping that straight, and we can do that with construction geometry. So the next thing that we would want to do, we could go ahead and put our keyway in there and put that hole in, but let's tackle those teeth. So I'm just rotating. I'm holding my middle mouse button down and rotating. And I'm going to choose this back surface as my sketch plane. So when I do that, I'm just going to click on that surface. And I can tell that it's a surface because I see that little square come up. If I'm at the edge, you'll see a line come up. So that's the difference between selecting the edge and the surface. It's telling you what you're selecting. So I'm going to select that surface and choose sketch. And if you remember, the distance there was 0.44 and that inside diameter was 1.5. So what we're going to do, again, we're just going to go straight up from the origin because in the assembly we can rotate it how we need to rotate it. So that's not going to be a problem for us. We're going to keep our sketches simple and go ahead and work off of that origin. So we're going to go back to center line. We're going to click on the origin and go up and just make sure. Right now you can see that I have two constraints showing up. I have a coincident and I have the vertical line. So I'm going to click on there. And once I do that, I can come in and I'm going to convert. I'll click on this edge. I'll convert it. So it's highlighted because now I have a closed loop. I'm not done, so I really, you know, it's highlighted, but we're still not done. We still have more to go as far as we're concerned there. The next thing that we can do is that inside diameter. We know that that's going to be 1.5. So we can create a circle from this origin, 1.5. And I'm just going to put a smart dimension on it. Okay. And so in order to make that tooth, I'm going to have to come down here and make these lines. So remember, we can offset that 0.44. And we're going to have to go back in. We made the other part straight down, but when we find this angle on here, I'm going to show you, I deliberately made the other one straight down, but I'm going to show you how we can modify a part in our assembly based on the geometry of another part. So right now on this one, we are going to make it at an angle like we're supposed to, and then we're going to update our other part in the assembly so I can show you how to edit a part through the assembly. So I don't know if you caught on to that, but that was intentional. So now we're going to have to figure out what that angle is, but we can still offset that 0.44 because we're going to need that as a construction dimension anyway. So we're going to go ahead and click on that center line. We'll go to offset. Now the whole distance is 0.44, but we're going to offset 0.22 because that's half, because we're coming from the center. And bidirectional should be checked. Go ahead and add dimensions so it'll be fully defined. And once we do that, we'll hit the check mark, so we'll hit OK. And we'll check that off. All right. Now, what we're going to do here is click on, we could do two different things. We could make this for construction, or we could come in here and make a point. If I click on this point, I can make a point right here at this intersection. And I can see that that's going to be an intersection because I have a different kind of icon coming up. Either way is fine. If you leave it as a line, you might actually see it a little bit better when we do a radial pattern for this. We're going to actually do a sketch pattern. So we're going to just leave it as a line, and I'm going to click on this line and tell it to be construction, and then click on this line and tell it also to be for construction. Because really all I need is this point and this point where it's an intersection. Because remember, our other lines aren't going to go straight down. It's going to be at an angle. We don't know quite what that angle is just yet. We're creating our geometry. This is one way to do it. We could actually do it a couple other ways. But right now what we want to do, we're going to click on this line. We're going to hold down Control or Shift, and we'll just select all three of those construction lines. Then we're going to come up here and go to Circular Sketch Pattern. And it's picking the origin as our sketch pattern, which is what we want. So this 0.1 right here is the origin. That's what we want, but we do not want 4 entities. We only want 3. So I'm going to choose 3 right here. I'm going to tell it to go angle of 360 degrees. So I'm good there, and I'm going to hit the check mark. Now the reason why I wanted that is because now I have all of those intersections, and I can get my angle, because all I have to do now is go from line, from this intersection here, all the way down to this intersection. Okay? And that's going to give me the angle that I need for my geometry. Remember that tooth was coming in at an angle? So I'm going to do that on all of these sides, but you make sure you're at the intersection on both of these. So we don't want to do the end point. We want to do the intersection where it intersects the circle and that construction line. So when it comes up, like when you're dangling over it, and when you're creating your line, this little icon is going to come up, and you're going to know that's the intersection. Now, if you don't have, let's say that you accidentally didn't get the intersection, you can click on the end point of that line, and you can hold down Control and click on the center line, and you can click on the circle, and it will allow you to put an intersection relation. So it knows that all 3 of those points should be intersected. So if it happens not to have this icon, then that's what we need to do. So again, to do that, you want to click on the end point of your line, hold down Control or Shift, either one will do, and choose the center line there, or the construction line, and then choose the outside circle. And we have all three of those entities selected, and then we can choose intersection, and it will put it on there for us. So really, we could go around and make all of these and just make the whole profile in our sketch, but we don't necessarily want to do that, because if we come in and end up having to change one of these, we're going to have to change all of them. So what we're going to do is just make one of them in the sketch and actually extrude it, just the one, and then make the radial pattern like we did before. So give me just a few seconds, guys, and I'll come around and help everybody. Let's get through this sketch, and I know some of you aren't with me, but we'll figure it out. So I have these parts. What I'm going to do, and the reason why I'm doing this, I'm going to make both of these for construction. It would be very simple to just think, oh, let's trim these. I don't want to trim them, because if I trim them, then it's no longer connected down here and I'll lose my angle. So I don't want to do that. I just want to make that for construction. And now I'm going to go back over. I don't have to make this again, because that's already a solid line. It's not a construction line. Also, this circle here is not for construction. It's an actual line too. But I'm just going to go take a regular line and go from that same point to this intersection here where it intersects that lower circle. And I'm going to do the same thing on the other side. So I'm going to go from that same intersection to the intersection here. So now if I have my profile, the only thing I have to trim is where the circles are. So my last step is to trim the circles. I just want to trim the outside areas of it. So I definitely want to trim, like right here I wanted to trim. I want to trim right here. The rest I can just keep, because I don't want my geometry to lose its relations. So down here again on this one, I'm just going to trim what I don't need on that part. Now it's showing up, it's still showing up that this is my closed loop, but if I wanted to be perfect on this sketch, I would tell this just to be for construction, and then any of the rest of this arc down here that I didn't trim, I would tell it to be for construction too. So I think that's my edge. It is. So I believe I've got, yeah, I got the rest of that arc. So anything that's not actually my profile, I want it to be for construction, because then I have no doubts about what my profile is, and plus it's a closed loop. So we did all of that just to make sure that we have this little profile here. So that was a pretty complex sketch, but now that we're all on the same page, we can check out of our sketch. Now when you check out of the sketch, if it clicks off, like if your sketch is not selected at all, and what happens when you go to extrude is it tells you, you know, do you want to start a new extrude or do you want to use an existing sketch? So this is where people get confused, because they see this yellow and they start worrying that they're doing something wrong. But all it's asking is, you know, you need to select something. So if you select the line of an existing sketch, then it understands that you want to use that sketch. You could also expand out your feature tree and click on the sketch here. So we need to know what that distance was, and I forgot off the top of my head what it was, so I'm going to toggle back over here. That distance, the whole thing is 1.38. So if we look at that, that's 1 3/8. minus the 0.625, basically 0.625, but it says 0.62, and then 0.25. So if we do the math on that, we need to know just this distance here. So we're going to have to figure that out, and I get 0.51 as that distance. So the distance from here to where the little teeth meet the geometry is going to be 0.51. So we're going to come back to SOLIDWORKS, and we're just going to type in 0.51 for our extrude distance. It would be 0.5, but since that 0.62 is rounded off, it ends up being 0.51. And we'll check that off. Yep. And so we can double check ourselves just to make sure, because in this picture it looks like it's longer than what it should be, but if we double check ourselves, we're seeing that this is 0.62 from here to this ledge plus a 0.25 and then subtracting 0.38. So it is going to look longer than what it is depicted in the pictorial there. So now we have our geometry, and it's Boss Extrude in here. Again, we could double click on that and change the name of it to tooth, or I'll just put angle tooth. That's going to help us later when we try to find some of our geometry to change it. Because remember, the other one we made straight down. So when we do the assembly, I'm going to show you how to fix that. Based on what we did here, but we're just going to copy this geometry instead of having to recreate all of that sketch. So now we've got the angle tooth. We need to actually create a circular pattern for it. So we're going to come back up here. We'll go to circular pattern. Remember, our direction is going to be the axis. So we're going to come back up here to the hide show and choose temporary axes. So it comes up so we can click on that center line. And we're only going to have 3 instances, so we're going to type in 3, and it wants us to select the feature. Last time we selected it before we went into the feature command. This time we didn't, so we have to come in here. I expanded out for the feature tree or the design tree, and I'm going to click on angle tooth, and it picks it up, and I'm going to check that off. So now I have this geometry that I need. And if I want to do like a zoom isometric, I can. And that's what it's going to look like. Now again, it's rotated in this pictorial view, but we can rotate it as we need to rotate it in the assembly. So we're not going to worry about that too much. Alright, so the last thing we have to do is put our keyway in and put this hole for our set screw. So the next thing we want to go ahead and do is the keyway. If we look at this keyway, it says 188 wide by 9 deep, so that is a typo, I'm afraid. We're gonna do a 1/4 inch keyway, so it's gonna be a 1/4 inch across here, and then it's gonna be half of the 1/4 inch here. So half of a 1/4 inch is 1/8 of an inch, so it's gonna be 1/8 of an inch tall and a 1/4 inch wide. I'll fix that typo, but for right now, that's what we're gonna do. So our keyway is gonna go here on this front surface. We're going to click on that surface and create a sketch. And just like we did with the last sketch, we're going to start out with a center line from the origin just up to the smaller circle. here. So we've made a center line from the origin to this smaller circle. We're going to offset on either side. You don't have what? Okay, look at your monitor where my mouse is. Right here where it has hide, that little eyeball, come in here and choose View Origins. Did it come up? Okay, so you're going to make a center line from that origin to the top of this object. Really, we only need part of it, but we'll just anchor it to the top just to do it. Then we're going to go to Offset Entities. We're going to click on that center line, and we're going to offset it 0.125 on either side because that's half of the 1/4 inch. So 0.125. And then we'll go ahead. That looks good. We're going to check that off. And then we're going to offset up 0.125. Okay? And where we offset up from, we're going to put just a line between this intersection where the offsetted line that we just made intersects the circle to this intersection. So make sure you're getting to the intersection of the circle and the line there. And if it happens that you don't, we'll go back and I'll show you how to do that. So right now, I think one of mine is coincident and then the other one isn't. So what I need to do to make that happen, the easiest thing to do is to go ahead and bring the circle in. So a lot of times we're skipping the Convert Entities part, but we need this circle in our sketch. It looks like it's there because we have existing geometry, but it's not really there. So we're going to click on that edge, hit Convert Entities so it actually is in our sketch. And then the way we're going to get that intersection relation showing up is we're going to click on the end point of our line. We're going to hold down Control or Shift, choose our circle that we just brought in, and then choose this line. And it's going to give us the option to do an intersection, and it actually shows up. So now we know we are exactly where we need to be. I'm going to go ahead and do it on this side too. So we're going to click on this endpoint. I'm holding down Control. I'm clicking on the circle. And I'm clicking on this line. So I have 3 entities over here selected. And it gives me the only options that we can do with all 3 of those entities is make them intersect. Okay, so if it is not possible as far as a geometric relation or constraint, it's not going to show up in this properties box. Okay, so the only option there would be fix, which we don't want, and intersection. We will hardly ever use the fix. So now I can see that it does have an intersection relation. Now that I have that fully constrained, I'm going to offset this up that 0.125 so I can make my keyway. So we're going to go back to Offset Entities. I'm going to choose, I guess I had my circle highlighted, but I do not want my circle highlighted. So I'm just going to make sure that I don't have anything highlighted. I'm going in here to offset. Again, it has my circle. I just unclicked it. I want this line. I want to offset this line, but I only want to go upward. I don't need this line. So I clicked on my line. I want this direction. I'm going to uncheck bidirectional. I don't want this one on bottom, but I do want it on top, so I'm going to select reverse to make it the top line. So I chose this line that I just made and put the relations on. I want to offset up from there. So you may have to hit reverse, you may not have to. So the only thing that you should have on here is add dimension, possibly reverse, and select chain doesn't matter because it's only one entity. And then our distance is going to be 0.125. So we can check that off. And now I have what I need. I just need to trim up. So I'm going to come in here to trim. I'm going to trim the top of this. It's telling me I'm fully confined, but let's keep trimming and see what it does. So it allowed me to be right there. I'm over defined, but if we keep trimming, so I ended up trimming this circle out, and it was okay for me. Okay, so I had to trim the circle because we didn't need it, and I trimmed the other lines that were sticking out. So we should be good there. And we are fully defined. So I'm going to check out of trim, check off of the sketch. And this is going to go all the way through to this surface. So when we do the extrude cut, we're going to click on extrude cut. We're going to go all the way through. Instead of saying blind right here, we're going to say up to surface, and we're going to check this surface and check that off. Yep, so if I go back in here and look at that, my surface that I chose is this back side, and I'm going to check that off. Nope, I just showed you that. So I'm going to choose up to surface, and I click on that back face because that's the surface that I want to go through to. The reason why we don't just say through all is because all of it goes out to here. So if there was some other kind of geometry that we needed to add, going through all would go through other geometry possibly, and we don't want that to happen. We want it to stop right here. Okay, then the last thing that we want to add is that little set screw hole. And when we're doing that set screw hole, we need to have a place for it to start. We cannot start a hole on a cylindrical object in SolidWorks. So we're going to have to choose our plane here, the top plane, to create that hole on. And then we can create it with the hole wizard and put what we need here, the 1/4 inch thread, 20 threads per inch, Unified National Course, internal thread. Okay, so the next step would be to choose the top plane. And our design intent was to keep everything symmetrical, so we still are symmetrical. Okay, the distance to the center of that hole is 0.31, and we're just lined up with the origin there. So we have 2 location dimensions. So we're going to go to the hole wizard. And the hole type is, it's going to be just a regular hole. So this third one, actually it should be threaded, so let's see. Let's do a straight tap. It's going to be threaded through all, so we won't have an end condition on that one. It's just going to go through all. So instead of saying bottoming tapped hole, we're just going to say tapped hole. And the size is a 1/4 inch thread, so we're going to choose that 1/4 inch, 20 threads per inch. And then the end condition is going to be up to next. What that allows it to do is just going to go straight through up to where our keyway is. So just to recap, I chose the tapped hole, which is the 4th one here. I chose the type to be tapped hole, 1/4 inch, 20 thread, up to next for the end condition, up to next for the thread because the whole thing is threaded. And then I'm going to go ahead and choose with thread call out. I can put the class of thread on there. By default, it's let me put a 2B, which is actually what I need. I do not need a countersink on either side, so I'm good there. And the call out, so it's giving me that call out, that's okay. As far as the tolerance and precision, I'm okay on it. So ANSI inch, tapped hole, 1/4 inch, 20, up to next on both of those. And with thread call out, thread class 2B. And then I'm going to go to position it. So when I click on position, I don't want to do a bunch of clicks here because every time you do a click, you're going to put a hole. But I do want to make sure I'm clicking on that center line. So my first click is on that center line. My next click, I'm going to come up here to Smart Dimension. And then I'm going to make a dimension from the center of that hole to that origin. And we said that was 0.31. So we have fully defined that because our one location dimension is the origin and the other is the distance from the origin. So I'm going to check that off. Check out the whole wizard. And now I have a hole. So it does not look like it's threaded, but if I hover over it, it does say 1/4 inch, 20 tapped hole. And on my drawing, on my engineering drawing, it will put the thread call out for me. Okay, and it'll also show that it's threaded, and you can actually see that internal thread there with that hidden line. That shows you that it is a threaded hole. All right, so now we are finished with this object. We need to go ahead and save. So we're going to have we're going to save it as coupler part 2. So we're going to go to File, Save As, and save it as coupler part 2. And remember, we only need 2 parts because the back coupler and the front coupler are the same. We're just going to insert those twice in our assembly. So for now, we completed the spacer, we completed the coupler, and when we come back, we're going to do the assembly.